This tutorial is going to focus on data structures in C#, specifically queues and stacks, since linked lists and arrays were done in weekly resources and on-track tasks. So this will help you to enhance your knowledge in data structures in C#. Firstly, data structures define the way data gets organized, stored, and based on this organizations, programs are being designed to take advantage of the operations that can be performed more easily. To enable using this, we use that system.collections.generic namespace, which consists of classes and interfaces pertaining to generic collections, and by using this we can get access to those stacks and queues and their relevant functions, and we can implement their functionality. So first up we will focus on queues. When seeing this picture, queues is quite analogous to the picture shown, where the data gets inserted from the end and it keeps on moving forward, similar to the way a queue functions, and the first one in the queue will be the first remove data from the queue. So basically it's first in first out. Who comes first will be served first and he will go out. And the operations associated are enqueue and dequeue, and enqueue happens at the rear end, that is it enters from the behind, and dequeue removal happens at the front side, so first in first out. The insert operation is called enqueue and remove operation is called dequeue. Now we will focus on the implementation of this. We will shift to Studio Code. Now I've just written this program where I have first brought in that system.collections.generic, and then similar to the way we defined linked list, we define a queue of type string name cars underscore queue, and then by defining this queue we have access to those functions that can be used to insert and remove elements. So enqueue function enables to add data by passing the parameters, where since we have defined it is of string type, so we pass a string called BMW, then accordingly I have passed 3 more cars. So I will just run to show what we have, what kind of structure we have as of now. .NET run. So after the enqueue operation, we have, since we inserted BMW in the very first, BMW in the first position, then Mercedes, and then at the end Porsche. So the elements are getting stacked. Just have a close look at how they are structured, because when I will going to run this commands for stack, you will see how the elements get stored there. So just remember that BMW is at the top and Porsche is at the end. Now I will just again go back to Studio Code and just uncomment this dequeue operation. So I'm just doing one dequeue operation on the queue, and I will just now again run the scheme.net run, and we discussed that the first element, since it was BMW, it should be removed, and here it is, BMW goes off, and then we are left with all the remaining elements. So this was all about queues. Now we will just focus on stacks. Just remember how the structure was. Now focusing on stacks. Stacks are similar to the way this image is, where the things keep on piling one above the other, and since we have only one entry point, that's the top, so the elements get added from the top and keep on piling one upon another and can be only removed from the top, and it follows the last in first out strategy as opposed to queues where it was first in first out, and the operation of inserting is called push. We keep on pushing the elements, and the element at the top is removed by the operation called pop, and the last element is first out, or it can be said as first in last out as well. And now focusing on the code, we shift to the code. We'll just comment the queues section out to help see the stacks a lot better, and I will just uncomment this stack code. Then I will just type skm.net1, and just see now that BMW was pushed first by that push function passing BMW, and if we see the structure, BMW is at the last position as opposed to BMW at the top in case of queue. So the element push first keeps on going down, and Porsche is at the top. Now you might be knowing what will happen in pop, but still I will run. Just guess what will happen if we implement the pop operation. I know you know it, what might happen, but I'll just run and show you what happens now. Here it is. The element at the top, Porsche, is being removed by the pop operation as expected. So after seeing all these outputs, you can see both the queues and stacks work exactly the opposite, and depending on the way last element and first element is being pushed, popped, NQ, DQ in these data structures, this working is being taken advantage by various programs to help get the implementation right. Thus, depending on the type of program what we need, we can use stacks or queues to deal with data. And for example, in queues, the first element that is being pushed will be getting out at the very first time, as opposed to stacks where the first element is going to get out at the last. So it makes sense to implement the code where if we need the first element to be accessed the very first, not at the last, so we can use the required data structure as and when needed. Thus, I hope this tutorial helps you to get started with these data structures and it proves useful to you. Thank you very much.